Hello and welcome back to the live stream. So last week we added support for arrays. We can declare an array, set access as members, and print them out. And most of it, the operations, we already implemented because this is all framed in terms of pointers. So the only thing that we really added was the part of the declaration, so that we can reserve here the appropriate amount of storage for that array. And the tricky thing is with arrays is that the size is a constant expression, and we need the size as a number as part of the AST. So here in the AST, the type of the variable is knows the size as a number. And we need to know that because we want to compare types for equality. We don't want to deal with like we could keep it as an expression, but then we need to do implement equality for expressions without evaluating them. So we want to evaluate them during compilation to get the size in the AST. This works fine with the simple example here. So we added this function constant eval integer expression, which does constant evaluation. However, it does constant evaluation of that expression in a brand new module. So within that module, we don't have access to anything else. This is problematic because C has gotten context per variables. So we have a context per size, and we want to declare the size of that. And that doesn't compile. It crashes because while we're doing constant evaluation, we have a fresh module. We don't know what size is because it's not part of our new module. So we need to somehow support constant evaluation by giving it access to all context per variable so we can do it properly. But the issue with there is that in general, a context per variable like this address here can access the address of another global. So what we really need, this compiles fine, and we've got the global address initialized to the address of this global. And then we also need the address of all other globals. So we can't really do the separate pass where we first generate AST, and then we generate code for it. We need to intermingle it. More precisely, during codegen, what we're doing is we're adding all forward declarations to the modules, and this needs to be done while we are compiling the AST. Because when we do constant evaluation, we do that in that existing module where we already know about all the forward declarations of the modules, globals, and so on. And then this should work. So this requires a refactoring. And instead of having single function to evaluate constant expressions and want to do codegen, we sort of need to turn the codegen into a library, and then the compiler calls into that library when necessary. So let's write a class. So class codegen. We definitely need a VM during codegen because we want to do constant evaluation. So that's our VM member. Now, do we want to store the AST? The issue is, so we definitely need the AST to do codegen. But the issue is that while we're compiling it, the AST is still incomplete. So the AST consists of the file, that's fine. The symbols, we know all the symbols so far, but the tree hasn't been completely built. So crucially, the root node is missing. So it doesn't really make sense to give it the AST by that point. So let's see why we're actually needing the AST during codegen. So we're storing the AST in the context as a member. So let's see what we're doing with that. So here we're setting it. Here we're doing a name lookup. So we need the symbol table to resolve names. Similar here. Then we also want to know the input. That's fine. And we want to query the location. Query the location. So we need the input and the location. Yeah. So we don't really need the AST to do general codegen. All we need is the symbol part of it. So this thing, the symbols, so we can resolve the intern symbols back into strings, and the location and input information. So yeah, this is all part of the input. So let's actually extract those in our diagnostic class. Let's, this includes the compiler, which in turn includes nothing. Why does it include the compiler? So instead of having the diagnostic, let's add infrastructure here to like remember the locations. So location, and I want to call it location manager, location. So it's a thing that allows us to get the locations. Locations. Let's just call it location. No, I don't want to call it manager. I don't like the term manager. Naming is hard. Locations. So let's just call it locations. It remembers a pointer to the file, which is what? Right, so the file consists of a buffer and a path. Let's also store it here. So let's see input buffer. So we store the file here. So we remember the file and the locations. So here node map and then the nodes. That's an alias. That's annoying. Oh, wait, we already got location here. So let's actually store that in that file then. So we got the file. And then the locations. We remember the file and then we remember the locations. Okay. So you don't need the file. Location. Probably let's just include the AST. AST. Okay. So now we've got a redefinition of file because it's at the bottom. Okay. Okay. So locations. File and then the actual map. Then we copy this function somewhere here, location off, by looking the location in the file. We get maybe I'm thinking about like storing a pointer to the file and then who owns that file object. What's the best design here? Maybe we do a different approach and add it to the file. Yeah, like so. That I like that. So the file keeps track of the input as well as the locations, which makes sense because the locations are just pointers into the input. So yeah, it makes sense that they are kept alive by that thing as well. And yeah. So then we get a constructor, turn it into a proper class. So it takes the buffer, UTF-8 char encoding buffer. I don't know whether I have various macros that I'm using instead of move. Every project I have defines its own. Do I have? I don't think I have one here for this project. Yeah. So let's just use the macro. Oh, maybe I don't have. Let's just use Lexi's macro. I know that one exists. Okay. So move that in. Then we want to get the path. So we also need the path as to the constructor. Thinking about, yeah, no, doesn't matter. Okay, so now I want the location of function of the file. So we get the location of a node by looking it up. And then like during compiler, we obviously, like we're using the location thingy to store the location. Oh, we're storing them right here. So we need a method to set the location. Location log by just inserting it into the map. And then for the like in codegen, we want to get is my language server still alive? Language server died. So I can't create the usage, but something input location of input location. Yeah. So we want to get the giving access to the entire buffer, because why not? Language server died. Can I find it here? Yeah, there it is. Okay. So let's get access to the entire buffer. Okay. Now, instead of storing the file information directly and separately the locations, we are storing just the file. And follow all errors. Now matching file to insert, why not? It would lose const qualifiers. Oh, can I do that? Okay, so use of undefined, that is correct. Input set location, that. Right, here I was too lazy to type the thing out. Lexi buffer, Lexi UTF-8 encoding. Reference to function must be called, yes. No variable constructor, sure. Context asked input location of file defined as a class. Yes, I did mean that. Reference to, okay. Reference to non-static data member must be called. So let's call it. Now matching constructor. Yes, I swapped the things around. Find a buffer. Let's also use the braces here. Would lose consequence, right? So we want to move that one out. So it has an overly qualified overload. That's why we need to move the thing and not the result. Because if you're calling it as an R value, we're getting an R value out. But if we're calling it as a const L value, we're only getting a const L value back. So we can't modify the buffer unless we are giving up ownership of the file object. Yes, because we are not needing you at the moment. Call to implicitly delete the default constructor of AST because input has no default constructor. Right. Where do we set the file? And we set that at the end where we move the input over. Okay, so we need to give you a constructor that takes the file as input, and then we need to get the AST, it's this third thing. Get the give you the input. Yeah, missing initializer, so let's give the ST a proper constructor. And I really need to debug at some point why my language server keeps crashing. It's probably because I write shitty code. Input, make you explicit. move the input in. Now permanent location of, yes. So state AST location of, state AST input location of. Yes, we need the file here. We're already passing it, so we need to move the file in, and then we get the file back from the state as input buffer. And then we don't need to set it at the end. Okay. So that's good. Let's commit that. And we don't want to codegen. Yep. Refactor class file. It now stores the node location map as well. Okay. So now we've got access to the file as a convenient thing that we can then pass to our codegen. So we know that the codegen needs the VM and it needs the file. So furthermore, the other thing it needs from the AST is the symbol tail, or rather the symbol mapping. So the AST stores intern strings, which are just this class, which is essentially an integer. And we want to set the names in the output to the proper names, so we need to turn that integer back into a string, and for that we need access to the symbol internal. Why is language server? Okay. Which is like a hash map of things and so on. So we need to give you access as well. So that's already a convenient thing. So let's just add an alias for convenience. So somewhere where we're defining the top level thing, like here, location, and so on. We are defining symbols. So let's also using ast symbol internal is that thing. So we are using 32-bit integers that map to char strings. That's what the template parameters say here. Okay, and so we can use that type here as symbol internal for the symbols. So now the codegen class also gets, let's just include the file because I can't forward declare a type alias. C-ast. So we get that as the symbol internal symbols. Okay, so now we've got all the necessary information here. So when we construct codegen, we are getting all of those things: the VM, the file, and the symbols. File, symbols. Symbols. Okay. And then we want methods like size t constant eval integer expression, given the expression. Right? And we also want to do a function finish codegen. Oh, let us call it finish. At which point you get finally the entire ST. Let's make it hourly qualified because you're sort of like it's the last thing that you call. So I like to hourly qualify them. So I'd like to indicate that afterwards the thing is no longer needed. And then we also need to do all that thing. So all of that thing. So we need a function to like codegen the global header and codegen the function header. So this one's called declare global given a variable and then declare function given a function. Okay. That's weird. So the idea is that while we are generating things, we are declaring globals or functions as necessary, and then when we call constant eval integer expression, it already has access to all of those. Yes, which means that we sort of need to turn like this codegen class is now our context, so we need to store the things that we previously needed in there, like the module. So that's the module that we are doing codegen on. Then we also need to we store a single global that we use for constant evaluation. We store the result of constant evaluation in one single global. And then we need the maps for variable decal to globals. And we need the map from functions, function decal to functions. So those are necessary because we populate them here basically, and then we later want to do lookup. We don't need to store the thing inside. So this one here for the local variables, because we don't need local variables for those functions. We only need it here, so we don't need to make it as a member. What we do want is to store the two builders, because the construction of builders is a bit expensive. So we're also storing them directly. They allocate beacons on the memory, so we want to reuse them. Actually, I think we don't need two separate. So we previously needed two separate ones, because we might, like, while we're doing constant eval using its builder, we might need the other builder. But this might no longer be the case. So let's just add a single one right here. So no other builder. Okay. And that should be it. Let's store it here. I like that ordering of members. Okay. That sounds good. So we now need to do more things in the constructor. So let's make it, let's start implementing things here. So codegen, not, yeah. We initialize those. We want to create a new module. So we're doing that like here by calling love as a create module. Main module. Then we want the Consteval with we want a builder. Love Adam create builder. Love Adam default build options. The Consteval result global by adding a global to our existing module with the permissions read write, like so. And then the maps are default constructed. Okay. Then we've got a function to declare a global. Codegen declare global. Declare global. But what was it? Codegen function global header or something? Header global header. So like so. We don't have context.mod, we've got underscore mod. And instead of context.ast.symbols, we are having, oh. So we're having star underscore symbols, and instead of globals.insert, we're having underscore globals.insert. Maybe it doesn't have underscore yet. It doesn't. Okay. So let's declare global. That one's easy. And we also want to declare a function. Declare function. Function header. So same deal. Star symbols. Underscore mod. Underscore functions.insert. Okay. Those ones are only called for globals. So that's fine. And also called for definitions. That's potentially problematic. So currently we are only generating the declarations when we have a definition. But this is potentially problematic. Let's do the same, and then you'll see that it is problematic and see if we can fix it. So this is most likely, this is definitely incorrect. But let's just get it working somewhat, and then we can fix that. Okay, so we have the ability to forward declare things now in the codegen. So the remaining thing, like we've got those two functions now. So cino codegen constant eval integer expression. And at this point, we need all this helper boilerplate stuff. So let's move them here to the top. Helper functions. So we've got codegen type. That one's easy because that is a pure function. And we've got actually two ones, type and layout. And those ones, they are all easy because they don't have access to the context anyway. So they don't need to be ported. Okay. Then we've got this function codegen L value. So codegen L value requires. Let's just see why we need the context, right? We want to access the globals and the local variables and so on. So let's add the context type back a bit, but modify it accordingly. Right. So we don't store the est or the vm because we don't need it at this point. We're storing a pointer to the globals, to the local variables, and to the so we're storing pointers here. And like so. We need that one in the constructor. So f.path Consteval. Okay. Okay. So that's the context. So now we can store those two pointers. All right, and then we also need codegen expression and the other one. So codegen expression. Codegen expression. Evaluates the expression as an R value using the builder from the context. You can also use the builder from the context. Okay. then we don't need the thing right here. And we don't need it here, since we're not passing it through. Okay. Oh, I don't need it here. 15J. Also don't need it here, and here. And that almost there. We've got many expressions here. Okay. So now we can do that. We now got the helper function that we need. Constant eval impl. Which we can insert. Confusing it. Let's use it after the expression. So it looks almost the same. So here we're now using a different builder, because we might do constant eval. Let's just use a single builder and see what happens. Constant eval builder. So you need the module now. So let's store the module in the context as well. And then you also need the other thing. You also need the const eval result global. Yeah. Okay. So let's also store that in the context. What's that the name? Consteval, not constant eval. Consteval result global. Stored in the context. So now that we've got that, now this one also needs the VM, but we can pass in. Let's just do it. Okay. VM. So now we should have everything that you need, except for the input. Okay. So that is the file input. Constant eval. This one. Right. So now this is just the input directly. Input location of. Okay. So that's constant eval impl, and so we should be able to implement you very easily now that we've got all that. But crucially, when we create a context, we can now pass in the existing module. And that's the entire point of this refactoring, to get access to the module while you're still doing constant evaluation. So we need the VM, the file, the module, the const eval result global, the globals. Now first we need our builder, then we need the globals, and then we need the functions. And you get a default initializer. And I'm missing a const qualifier right here. Okay. So now we can reuse the existing context during constant evaluation. So now what's left to do is to do the actual one where we do codegen the function body. We don't need you anymore. So those two functions. This one actually we don't need. So those two. To actually finish the so you can use a pointer. You can use a pointer. You use the regular builder. Context input. Factoring right here. So when we go to the equation, we pass you around. Okay. Which means that now the actual codegen function can be called codegen finish. We construct the context in the same way right here, so we can get access to the existing stuff. We don't have any parameters. Oh, no, we get the ST. We don't need the forward declarations because we already did that by calling the other one, so we now just codegen this one. And I've kept you around because we need to add the destructor to codegen. So we want to destroy the builder and make it non-copyable as well. Okay. So that's the new interface. And now all we need to do is adjust the compiler code. So first of all, the compiler itself also needs to get access. So we want to actually change it so like so we actually make it codegen completely. So instead of returning an optional AST, return a compilation result, which contains the AST, but also the module. Okay, so I actually need to include the AST at that point. That is a bit annoying, but oh well. AST. So we return an optional compilation result. Okay. Compilation result. So the compiler state now also stores codegen. Codegen, which we are constructing by giving you what you want, which is the VM, the input of the AST, and what was the final parameter? The symbols from the AST. Okay. Then we also need to separately store the VM because we only needed it to pass things around. Oh, I'm getting Wi-Fi issues. Let's hope it keeps working. So now we can get the codegen, which means that here we are calling codegen finished to get the module. And then here we're returning the AST together with the module. Right, and of course you don't have a matching constructor for that. Compilation result. Okay, so that's the high-level changes. And now we just need to call the function that declares the globals in the appropriate places. So when we have a declaration, somewhere in here, we are creating a general declaration in the decl list. And when we do so, we also need to add it to the going on. Let's fix it. So decl. So now we get the declaration that we just added, and we need to forward it. Codegen state codegen, right? Declare function or declare global. So triad node try cast. So if we're having a function decl, codegen declare function. Otherwise, if we're having a variable, okay, sorry about that. I don't know what's going on with the Wi-Fi. So if we're having a global variable, which means storage duration, so global in this case means that not the visibility, but the actual storage duration. So if the storage duration is static, then this is a global. Maybe the name is not declare global. Like so. And the other thing is a compilation error. No matching function. Oh, okay. Result. Of course, we need to result star AST. Get the let's actually be fancy and use that syntax. But that's not the error that I wanted to fix. I wanted to fix that one. Right, so instead of calling this non-existing function, we're calling state codegen constant eval integer expression of the size during the array. Okay. Wi-Fi's, sorry, the Wi-Fi is spotty. Wait, I'm using Lexi move. Oh, that's a bad bug that I should fix in the upstream dependency. I have too many move macros. Right, I'm getting sec false for everything. For literally every single test. Okay, so let's see what's going on. Let me guess, we don't have the function. So we're trying to generate the decl for. So what's the thing? Right here, this one. I think I know what the issue is. So right here, somewhere. So when we pass a declaration, we generate the thing. Right here, we are declaring the function. But global declaration triggers a different bunch where we're not doing that. So, right. So if you have a function body, then we're not getting this code. So, right. We have got a function insert new decal, and we should use that one instead. I'm pretty sure we're calling that one when. So let's put that in there. Insert new decal. So this one checks if it's already a thing. Right. So let's do it at the very beginning. Right, so decal. Inform codegen of the new declaration if necessary. Okay, here's the question. Same deal. Why though? So let's see, do we ever trigger this code? We do for that address. That appears to be the same address. So why aren't you part of the functions? Do we not add it? I don't have Linux server again. Declare function. Yeah, we insert it here. So it should become part of the map. Unless it's... okay. I think the issue is that at this point, when we generate the function, when we're calling insert new... hang on. So when we're calling insert new decal, we don't have a definition yet. Oh. It helps if I can use my debugger. Right, it's not the definition yet because we're calling it here before we make it a definition. So I need to do that later, but the thing is, I still, so I need to insert call that thing after I pass the body, but I can't call insert new decal after passing the body because then recursion would be impossible because the name of the function would not be known while we are passing the body. So I can't just hook that insert new decal. I need to use codegen new decal. Like split it into two functions. Decal. Like so. And then when we passing a declaration, so at some point I'm guessing we're calling insert new decal. Where do we call insert new decal? For decals didn't in a bunch of places. Oh wow. Okay, so every time we're calling insert new decal, we also need to call the other one, if necessary. So here we can call it directly. Here we need to call it after the body. And here, we're not doing anything to codegen a function parameter at this point, but let's just call it here for consistency. Okay, we're still crashing. Now we are forgetting to codegen a global. Okay, let's see how many. Right. But I can find a simpler test. Forward decal seems complicated. Global.c should be a simple one. Yes, it is. I wanted to add a breakpoint. Right here. But first, simplify this one. You should, that one should still crash, yes. What if we don't have the function local static? Still crash. Okay, so that's a simple test case now. Apparently, whenever calling codegen declare global at all, which seems a bit weird. Do we call this function? Yes, for a function. We're not calling it for globals? Wait, really? Okay, again, sorry, I have Wi-Fi problems, apparently. I'm back now. So apparently we're not going to decal for globals, which is a bit odd, because we're calling insert, we're not calling insert new decals for globals. So we're only calling it for decal statements. Why are we not calling it for declarations, I wonder? So when we have... right, because we are triggering this code that passes a global decal, I believe. So we are passing a translation unit is a sequences of global declarations. So this one is used to pass our global. And not calling codegen, yes. That is in fact true. Codegen new decal state decal. And now all our tests actually pass. I'm surprised by that. I'm really surprised by that. So let's commit that. Refactor codegen to support array constant evaluation. So why I'm surprised by that? I'm surprised by that because apparently code like this. So when I have a global and to store its address in a const expr variable, that's allowed because the address of a global is const expr. So that's allowed. That should compile. And it does, and we are like getting the address of the. Let me actually print something. So we can see of print. This should be the address of the global. And that is true. Okay, so that one works. And it works because when we're passing the definition of this global, we are doing codegen for its declaration. So at this point, we're adding the global to the module. And then when we do the codegen for the const expr thingy, it is available. Now, what if I do that? Now we don't have a definition for the global. Okay. I did not expect that error, to be honest. No, it makes sense. So because we're using the global, but it hasn't been defined. I wonder why we're crashing though. That's not good. That's really not good. That is bad that we're crashing here. Why do we not have the location of the deck? Oh, that is bad. So what is the position exactly? It appears to be the position of that thing. Wait, the input is... Oh, that is bad. The input is empty. Why is the input empty? Because... So apparently file buffer has been moved from... Oh, why has it been moved from? Why has it been moved from? Okay, you know what? So the AST... so we get the input, and then we're moving that into the... Oh, yes. So it's been moved from, because we're storing here the address to that reference and not to the one in the AST. Okay, that's a bad bug. Okay, logger input. Okay. So now we should no longer be crashing, but instead get a proper diagnostic. Apparently not. Oh, well, obviously, then I also need the AST input. Okay. So now we're storing the correct pointer, and we're getting an undefined declaration of global. Yes, which is true. Ignore the Unicode garbage there, that's just part of NeoVim and not of our output. So this error actually makes sense. Let's commit that fix. Fix use after move in diagnostics. Okay, so why do you work? So the thing is, while we are doing stuff... I know it works. So the issue is when we're calling declare global in codegen for that global. But the first thing declare global does is it checks whether we have a definition. And if we don't have a definition, we get out of there. Hang on, I need to do something with the chat. Okay. So if we don't do codegen. So how is it able to get the address of that thing if it hasn't been added to the module at that point? And the answer is we are not actually doing constant initialization of context per variables at this point. So it works fine because we're only doing it at the very end to be actually initialize a context per int. Only if we now start using it as an array index would we run into the issue, but we can't run into that issue because you cannot use an address as an array size, if that makes sense. So it actually works. Does it work what I wanted to do? So context per int size 11, array of size. And that one doesn't work. Okay, so let's investigate why it doesn't work. We're creating an array of 8 elements, which is obviously wrong. I wonder what happens. 0, 0, array 1, 1. Yeah, getting a panic because we simply don't have enough space. So why do we think... thanks for the comment. So why do we think the size is 1 and not 11? Does it matter what has happened there? It does not. That's always 1. Okay. So this should be in a constant eval integer expression right here. So so we're doing codegen for that expression. This should eventually trigger, we've got an identifier expression. So we codegen an L value. I think I know what might be the issue here. So eventually we reach this branch, right? So that's the thing, and it's a variable decal, so we now try to resolve it. It's a global variable, so we push the value of that global into the stack and return. Interesting. I believe I know what the issue is. And now if we continue on, we should eventually, hang on, this is impossible to debug. So we got now the address, and now we've got somewhere in there, we've got the L value to R value conversion. Yeah, decay expression. Maybe not. Oh, hang on. I think I know what the here the AST looks something like this. We've got the size of the array is an identifier expression, and when we codegen an identifier expression, we get its address. This is to make something like so. So here on the left-hand side, so we got the left-hand side is an identifier expression, which evaluates to its expression. If we actually want the value, we need a decay expression. So the decay expression turns the variable, so the address, back into the value, which we are apparently not doing here. So what we are actually evaluating here is not the value of size, we're getting its address. And it just happens that the address is like as interpreted as an integer as 1. So yeah. So that's actually an easy fix in principle. Somewhere we are parsing in the declarator somewhere. So when we pass a declarator, we create an array declarator right here, and we don't want to do constant eval of the integer expression. We want to do constant eval of the decayed integer expression. State, so we need a new AST. State, hang on, how do we actually pass that one? Okay, so state AST, we want to create a clove decay expression. At the input location of the of the current thing or whatever. And we want to, what's the parameters here? Decay expression, target type and chart. And the target type is the same type, because the L value R valueness isn't part of the type system in C. So in C++ we would like convert it between, or maybe, I don't know, so the same type, but of that expression. And now we should not get the address of that thing, but the actual value of that thing. Panic during constant evaluation. Great. What's the panic message? Invalid address. Right. Okay. Okay, so now we are trying to dereference the address to get the value that's stored in there, but Lauf doesn't want that because the thing is invalid. So let's debug that. So when we do codegen impl, constant eval impl, or what's it called? Constant eval impl, right here. So we're calling our panic handler. Why are we calling our panic handler? But it's good that we're actually now trying to evaluate you. Let me get rid of the existing breakpoints. Okay, so we are panicking. Because... right. Okay, so I don't actually... So I want to know which instruction causes it, but or rather why that is called. But I don't have a backtrace in here, so we're dereferencing something. Deref cons, so you are failing. So I need to get a breakpoint here and get it correctly. Okay, so we're getting the address that's on the stack, and we're trying to get an allocation out of it. So we have an allocation, and that allocation is still valid. So we have an allocation. So now we want to do offset into that allocation. So that is our allocation. And it's empty, which is why we're getting an invalid address. Why is it empty? I know why it's empty. Because by this point, we haven't initialized the global yet. We called declare global for our global size variable, which adds it, but doesn't add an initializer. So we need to initialize that thing by this point already. So we've got a function codegen global init. Yes, and we only need to initialize. So we don't need to initialize all globals, only those that can be accessed during Consteval. So let's call it initialize const expr global decker. And what you can do is declare global somewhere afterwards. Simply all you can do codegen initialize global. And what you can do is we're just calling codegen global init with a new context here. So context codegen global init context decker. Okay, and then we need to call that when we codegen a declaration right here. If it's static, if it's furthermore constexpr, then we also want to initialize the constexpr global. And hey, wait, no, that's still wrong. Oh, no, actually, come on, Python. 42 times 8. 336. Yes, that's correct. We created an array with the correct size, initialized by constexpr variable. Great. I don't like this thing because the first thing this function does is create do a lookup in the map. So let's actually do it inline. So when we declare global, if it's constexpr, for constexpr global, we need to set its value immediately, as it can be accessed during integer constant evaluation. And so we need an initializer. So now we're calling you here. And let's actually change this function. So you get the global as a parameter. So, and then we do the lookup here. Context globals lookup for that decker. And then we can, like, it's a micro optimization, but it's nicer code. Right, of course. Then I don't actually want you anymore. Right, so this is now done for us. Uh-huh. I'm getting a linker error. I don't have, like, linker errors don't show up in my prompt here. Why am I getting a linker error? Undefined symbol, codegen constant eval integer expression. What? Oh, I might have simply deleted too much here. Ah, yes. I've accidentally deleted that definition. Okay. So now those tests still pass and the code is nicer. Okay. And that was the books. We get like the huge array and excellent. Okay. Initialize support const expel variables in array size. Okay. And just to get it like let's combine it with like size minus 11 or something, and then we should get. Oh, okay. So that one doesn't work either. Why does that one not work? I might have an idea why that one doesn't work. Okay, so same deal. Somewhere we've got the panic handler. Let's add a breakpoint. We are getting called during the execution of the ref const again. Why are we called during the execution of the ref const? So we don't have an allocation for that address. Okay. Something weird is going on during codegen. So let's codegen constant eval. Let's actually print the bytecode that we're executing here. How do we best do that? So we want to print the bytecode of the constant expression evaluation that we are printing. So, okay, let me include backend dump. So at this point, we want to dump the module. Backend dump love write to standard out default options of the current module. Okay, let's see. Right, we're not actually getting the chunk. So we need to. So while we're doing constant evaluation, when we want to dump it, we don't get the bytecode for the chunk because it's not really part of the module. So let's hack that. Dump function writer options mod chunk function. Okay, let's see what's going on. So the last one fails during constant evaluation. What's 2a? Okay. Python thing is really slow while I'm streaming. That's 42. So this, I believe that one is the one that is failing. Right? Now we're violating that expression. So why are we pushing 42 onto the stack at all? Shouldn't the other one fail? Why do I have 2 1? So that one, so apparently that one panics. I'm assuming that it's the bytecode that we're executing. Wait, no, we're panicking on the deref const thing. What the hell's going on? So we're panicking here on a deref const. So where's the deref const instruction? Ah, that is this chunk. Okay, this chunk. So we are loading the global value stored in size. Okay. We are pushing b, which is 11. Yes. We are calling a subtraction. Then we're debuffing. What? Oh, okay. So here we're doing, like, we are subtracting 42 minus 11. Let's get rid of bytecode. Oh, interesting. So 42 minus 11 is 35. And then we're dereferencing it. And obviously that one fails, because we don't have anything to dereference. And the reason we don't have video referencing it is because that is what decay expression does. Right here. So we're unconditionally creating decay expression, even though we don't need to decay it because it's not an L value. So we need to do an L value conversion here. Got a function for that. We need to do that conditionally. State as input location of the expression, and not unconditionally decayed. And now that one works. Let's restore code then, so we can actually see what's going on. Let's also let's print something. Oh, actually, somewhere in here. 248. Why do I keep calling Python? Let's see whether that is the correct value. 42 minus 11. 31 times 8, 248. Okay, so that one works. Fix bug where we create too many decay expressions in array size. Okay, now before I end the stream, I want to do 2 things. First of all, now that we're printing the chunks, we can see that we have a bunch. So we have a chunk to initialize compute the initializer for the context per size. Then we have one for the computation of the array size. And then we're having another one. Okay, so apparently we're initializing the context by global twice. I know why. When we're calling it here. So we don't need to reinitialize things that are context bar. We need to initialize all globals. Globals that haven't been initialized at that point. No, let's try to initialize all non-context bar globals, because that hasn't happened before. Okay. So now we should only initialize it once. So we've got 2 chunks now, one to compute the array size and one to initialize the size value. Of course, the entire purpose of a chunk is to be a container for temporary bytecode. So we can reuse chunks. So instead of creating a new chunk that holds bytecode, every time we do constant evaluation, we are creating a single one during codegen. So similar to the one here, we are also having a chunk. So the const eval chunk. Yes. And then during codegen, the constructor adds the const result global and the const eval chunk. Create chunk in our module. And for some reason I gave them the different order. Okay. And then when we do the const eval impl, we are getting the chunk from the context, const eval chunk. Of course, there isn't one, so we add one. Chunk const eval chunk. And then we need to just, when we create the context, we need to adjust that. Const eval chunk. Const eval chunk. Const eval chunk. Like, okay. And so now we should only have one chunk, right? So one chunk, and it just holds the thing that we initialized last. And we can reuse its memory. This also why it's not dumped unless I hack that in, because like it's just a temporary container that can be reused. Okay, let's commit that. Reuse chunks during constant evaluation. And then finally, there's one last thing. I do not support variable length arrays. Right. So I should get a better error message here. So let's catch that during. Let's actually, while we're here, I don't want to catch that exception. Since I'm only using it, so like when I do constant evaluation, like here I'm catching exceptions during its panic handler, and I also want to do that right here. And then I just return 0 or something. Okay. Right, and then I get panic during constant evaluation, but compilation can still continue. Yes, and then I'm getting another panic again later on. So I need to somehow flag this error. So in compiler, right, because I'm using a different logger here. So I'm not flagging this diagnostic. So I need to actually pass in the logger. Const diagnostic logger that we should be using. Let's make it the second parameter. Diagnostic logger, so we pass in a logger. Diagnostic logger. Okay. And then the context itself. Now actually, where we do constant eval impl, right here, I don't want to create a logger, I want to use the logger from the context. context logger log. So we need to add yet another thing to the context. This is such a horrible struct. Const diagnostic logger logger. And apparently it cannot be const. So now I need to propagate the mutability outwards. So you cannot be const. And you cannot be const. So pass in the logger when necessary. Okay, and then right here we are also giving you our logger. And now we should pass in the flag that we've got an error. Okay. So fix panic during constant evaluation. Error reporting. But obviously the correct thing is we don't want to do a panic with like a weird error message. We want to say that variable length arrays are not supported. And we do that by parsing the declarator somewhere where we create an array thingy right here. If so we get the size somehow. If expression is so if we are having an integer constant expression, is integer constant expression. We defined that a while back. Then we can do constant eval of that integer constant expression. Otherwise, we want to issue a diagnostic. State logger log zero diagnostic kind error. Variable length arrays are not supported. Annotation, primary annotation, whatever. Do we have a position? Maybe not. Apparently not. Here. Finish. So I don't have a position. Nothing that can't be fixed. We're getting one right here. Let's call it log for consistency. And then we continue with the zero sums. Just to continue parsing. And of course, this is now a safety. Here we go. And oh. What? Okay. So where do we fail? We want to visit something. We are missing a visitor. An arithmetic constant. Right. So we recently added the decay expression, and we are missing that in a bunch of places. So decay expression, essentially, like they can be treated like a cast expression in most cases. So let's just see wherever we're using a cast expression. Not here. This is just at the updated. Is address constant? I don't think this one matters here, but let's just say if it's a cast expression. So an address constant is like a thing that is a constant address. And we support the address of operator of a static L value. We don't support identifier, so this one doesn't matter. Okay. Variable length arrays are not supported. Great. So with that, we're done for this today. Generate diagnostic for VLAs. Next week, we will continue with arrays and start working on array initializers. So we can do something like that. Okay. Thanks everybody who stopped by, and until then.